Good afternoon. So, welcome to the today's session, which is in continuation with our last session on non-special database. And in the last lectures, we have covered the basic concept of databases and why we should use the database and what are the advantages. And also, we have seen the importance of this database management system with respect to GIS up to some extent. Of course, the later stage you will be learning about the special databases in some other lecture. And during the last sessions, we were discussing about the models of the reality, and as it was explained that and the model is basically the abstract representation of the reality. And when I'm saying the abstract representation of the reality, and it is basically idea to simulate the real world problem in the computer system. Now we'll continue. The next question comes, why we should use the model, what is the advantage, and why we should simulate or why we should create the abstract representation of the reality in the computer system. If you see, the models can be useful when we want to examine or manage part of the real world, and the cost of using a model are often considerably lower than the cost of using the experimenting with the real world itself. So this is just a effort, you can say, to reduce the cost of our experiment by implementing the model in the computer system. Some of the examples you can understand here, like airplane simulators. If you see here, if you want to understand the operation of airplane, so that can be simulated in the computer system very easily, and experiment can be done. Similarly, the nuclear power plant simulators, flood warning system, model of some US or Indian economy system, model of heat reservoir or map. So if you see here, the map itself is a model. Other than typical example what I have listed here. So map is one of the important model what we will understand, we'll try to understand in this particular course. If you see here, the map is a model of reality. You can see this word map is shown here, and it is a representation of this reality world in the computer system or maybe in the form of the atlas. So now database management system will help you to create the abstract representation of reality. So that means it will help you to model the real world problems in the form of the database. And when you will be creating the database, it will provide you various utilities, various tools to process, to analyze this database. Now the next question comes, when I should use this DBMS, when I should not use the DBMS. As I mentioned that it is one of the model or method to create the model of the reality, but there are many other such models exist, such as your file-based system. If you use a DBMS, when this is important, the important is persistent storage of data, and you need a centralized control of the data. If it is a requirement of your projects that your data should be centralized control, it should have the centralized control, then definitely you should use the database management system. And if it is a demand of your project or your research or your study to control the redundancy in your data, then DBMS you must use it, because DBMS will provide you the facility to reduce the redundancy by setting up the different rules, by setting the different relationship. If you have requirement to control of the consistency and the integrity in your database or in your data, then definitely you should use the DBMS system, and multiple user support is required. If your project or your data demands to access the data from multiple users, or you are going to set up a multi-user environment, that time the DBMS must be used, and it will provide the excellent tools or platform for such activities. Another thing is, if you require the sharing of the data, if you have data documentations, data independence, control of access and security, very important. So if you want to apply a excellent data security especially when you are working in the multi-user environment like your internet environment, or you are developing internet applications. That time, by introducing the database management system in your projects, so you are going to add an additional security layer in your applications, which database will provide you. And most important is data backup and recovery. So if your project demands that, you should have a strong data backup and data recovery system, because in the any digital medium, either it is a hard disk or it is a simple USB disk, or maybe it is a some other mode of data storage like NAS and DAS and all. So there is not at all 100% safety of any data. Anytime the device can fail, or you are very much concerned about the strong backup of your database, so that you can recover the database in a shortest time period when there is some emergency or disaster in your data sets. So these are the very critical points what I have listed here when you should use the database. Parallelly, I can say that when we should not use DBMS, because DBMS or database management system is not the solution of all the problems of related to data. It is not the solution of all the problems related to data. If the initial investment in hardware, software and training is too high, then you should not use the DBMS. That time you can use with the normal computer PC to store your data sets. And generally a database management system provide is not needed. So sometimes in generality, if DBMS is not available for you and it is not required for you, so definitely it is not necessary every time that forcibly you should not use it. The overhead of the security, concurrency control and recovery is too high. That time also you should not use the DBMS. Data in applications are simple and stable. If you feel that your data, the desktop based application which is working on the file based systems are okay, are performing well with your database, it is not necessary every time to move your application with DBMS. Real time requirements cannot be met by it. Okay, if sometimes it is not possible, or it is a real time problem is not possible to met with this, so should not use it. Multiple user access is not needed. If only single user is there, or you are going to share your application or your package as a CD based applications or DVD based applications, that time also it is not required to use the database management system. And the database design, especially for the non-special data, the purpose of database design is to create the database which is model of the structures of the reality. It supports the queries and update modeling process of the reality and runs efficiently. These are the three major characteristics of any database design, what you have to see very carefully when you are designing the database, especially for the non-special data. And the abstraction, it is very important that the language used for the data representation support abstractions. We will discuss three kinds of abstraction here: the classification, aggregations and generalization. So abstraction is very, very important. When I am saying the abstract representation of the reality, that is a very, very important keywords what you have to understand when you are implementing the DBMS for your data sets. So how you are going to classify the real world, how you are going to aggregate, and how you are going to generalize this, that is very important for the abstraction of the real world problems in the computer system. So in this case, the data model plays a very key role and plays a very important role. Basically, it consists of notation for the expressing the data structures, integrity constraint and operations. These are the three important parameters which are required to define a data model. So what basic thing is structure. What is the structure of your data? Basically, it is known as a schema. And then second is a integrity constraint. And then third is what are the operations are permitted with this data, which need to be defined in the model itself. Now if you see the data model, data structure point of view, so all data model have the notation for defining. Like you can see here, this is a typical example what I am showing you. Here the two tables. One table is basically, for example, I have shown as a flight schedule. Second is a departure and airport. You can see here the flight number, airlines, weekdays, and price. So here if you see the entity type is known as a flight schedule. This is a entity type, and the attribute type you can see here like weekdays, price, airlines, flight number. These are the attribute types. For example, the airline is a name basically as a textual or a text data type it is represented, and the flight number is represented as a number. And same with the price as a number. The price cannot be a tax, it cannot be characters. In this case, this is a basically attribute type. The same thing if you see the departure airport, from which airport it is going to depart, you can see here again in this particular table the airport code and the flight number 2 are attribute, but the flight number is a common in both the tables. So here you can see this particular flight number can be used, this particular attribute can be used to establish the relationship between these two entities. So very important, if I want make the relationship between the flight schedule and departure airport, then flight number is more than sufficient to define the relationship between these two entities. So this is a typical example of the data structure when we are creating data model. Now if you see the constraint, very important, and constraint basically express the rule that cannot be expressed by the data structure alone. Very important, and what kind of limitations or what kind of policies we are applying on these data sets are very important. Like you can see here, the static constraint apply to database state and dynamic constraint apply to change of database state. For example, all flight schedule entities must have the precisely one departure airport relationship. So whatever flight number I am mentioning in this flight schedule table, this particular all the record must have one airport from where it is going to depart. So departure airport is must. So this is a relationship between the flight numbers. So flight number 101 will depart from say this particular airport. So this is the relationship between these two things what we can establish. And the operations, what is this operation? Because during the data models, data structure, we basically talk about the operations, and here the operations support change and retrieval of data like insert flight schedule 97 delta TU 258. This is basically we are inserting a record in a table say flight schedule, and then it is a operation called insert operations. Insert is basically to make a new entry in this particular table. When the entry is made in this table, then the further entry for departure airport can be made in another table, and the relationship between these two are already established and a typical operation can be performed. And then if you see the selection of data from this particular data sets, how you will be extracting the information from here. You see here, so select flight number, weekdays from flight schedule where airline is equal to delta. The airline delta, all the flights from this particular airlines will be listed or will be extracted from this query, and this is a typical operation of selection. So there are different kind of operations available in database: insert, insertion, deletion, and selection. These are the three major operations. Other than we have the data table creations or alter table, that is for the modifying the table. These are the operation for data structure. Now if you see the key identification is another important point when you are designing a database or when you are designing data structures. Like key basically are uniqueness constraint. So yesterday also I discussed about the unique representation of a record is known as a key, and there are different kind of key we discussed yesterday. And here you can see a key on the flight number, what is shown here. In a flight schedule, will force all flight number to be unique in the flight schedule. So in this particular table of flight schedule, the 101 or flight number will be unique key. So this particular number will not be repeated at any times. So that will be basically unique identification of this particular flight number. And consider the following key on the departure airport. The same key in depart airport you can see here. So this same flight where it has the unique entry here, and this particular flight can depart from multiple airport also. So this entry can be made here as a multiple entry, that is possible. And integrity and consistency is another important characteristics or parameters for designing the database. When you are talking about the integrity, does the model reflect the reality well? So integrity of your data is very important, and whatever database design or whatever structure you are designing for your database, it should have a good integrity basically of your design. The consistency, data must be consistent. Is the model without internal conflict? If flight number is flight schedule cannot be null because it model the existence of an entity in the real world. So you cannot do any entry with flight number as a blank or flight number as a 0. So this is not permitted here. So consistency is very important. A flight number in departure airport must exist in flight schedule because it doesn't make sense for a non-existing flight schedule entry to have a departure airport. So very important point. This is basically a foreign key concept or referencing integrity. We use the terminology. If any flight is not entered in this particular flight schedule, but their departure airport is mentioned here, then this data cannot be considered as a consistent data, or this kind of data is with a full error of, because if any entry is made here in the departure airport, this particular entry must have some record in the flight schedule table. So this kind of relationship or integrity or reference integrity can be maintained in database design, and we should consider it very carefully. Next important terminology in the non-spatial data is a normalization of the data table. And normalization basically idea is step-by-step decomposition of larger table into smaller table. And here you can see if there is some complexity in database or in data there is some duplicacy in the record, by using the concept of normalization we can break down this big table in a smaller table, and then we can set up a relationship between these data entities, and the further data can be presented for analysis and processing. So you have to remember here, so normalization is another important activity for database design, which a designer should be carefully analyze and can design the better, or I can say is a normalized structure of the database. So now next point in the data model comes is a how you will be creating this model. So there is something called ER model, entity relationship model. We have the hierarchical model, network model, and inverted model, relationship model, object-oriented model. There are different type of data models available for the non-spatial data. And if you see that typically the ER model is basically a graphical representation of your database design, and it is just a graphical presentation, not in the implementation level. This is a typical example of the ER model. To understand graphically the data design and data structure, we'll design the ER model. Here, if you see the ER model, there are some different kind of notations are being used here. You can see here the entity type as a rectangle, relationship type as a this kind of this box, it's a square kind of things, and then this is attribute, and it is a multi-valued attribute, and this is for derived attribute. These are the standard parameters or the different notations for the designing ER diagram which are available in the non-spatial data model. Now if I summarize this entire database concept, you can see that the DBMS is used to maintain and query large data sets. The keyword is a large data sets. A benefit include recovery from the system crashes, concurrent access, quick application development, data integrity, and security. These are the different advantages to use the DBMS. Most important is a recovery of data from system crashes. Very quickly or very easily you can recover the data. And then we have the level of abstraction which gives data independence. A DBMS typically has the layered architectures, and DBMS R&D is one of the broadest, most exciting area in computer science, because most of the time we work with the database and the data is coming from different sources. Today, many new terminologies people are started to use, like big data analytics, and people are using the concept of your parallel computing, distributed file system, NoSQL, and these are the some advancement in the database technology where the large unstructured data is being handled by these database designs or architectures. Now, come to the most interesting data model for GIS, which is called as a relational data model. And the relational data model is a data model what we will be using in GIS for our non-spatial data management system. And basically, this particular model was introduced by Dr. E.F. Cord in 1970 time period. Dr. Cord was a French mathematician who has given a set of rule for database management system. Of if any database management system is compliant with these 12 rules, then it will be considered as RDBMS. Sometimes the students are confused that if I have some relationship in my tables, relationship in my database, then it is a relation database. No, it is not the things. Yes, the relationships are there, are required, are necessary, but are not only criteria to define a database as a relation database management system. If you want to say that a particular DBMS is either RDBMS or not, that then your DB must comply with this all 12 rules what we are going to discuss now. Then it will be known as a RDBMS. The ER model is used for the conceptual modeling purpose in the RDBMS. So basically, first graphically we'll design the database and their relationship and attribute type all. Then after that it will be implemented in database management system. So here you can see relationship from very simple to powerful and flexible. Relationship can be established here, and basically when we are saying that relation, then it is basically a table which is being used, and first it was proposed by Dr. Cord in 1970, is the basis for the relation database management system concept. And if you see that in any RDBMS, it consists of a collection of tables, collection of rules, constraint for how tables are arranged, a set of operations to act on the tables. So very interesting definition is given here. RDBMS consists of collection of table. So here all the data sets, in fact all type of data is being organized as a table format, and on these tables will define some rules and relationship, and then we'll be arranging this table with the relationship and the data will be organized. A set of operations to act on this table are very important. Once you organize the data in a tables, then what kind of operation you can perform on that. An operation means it can be a data insertion, deletion, updations, or maybe selection, or sometimes the analysis itself, or maybe some arithmetic operations or some mathematical operation. If you want to operate on that, it is possible. So what are these rules which are defined by Dr. E.F. Cord, known as Cord's rule on RDBMS? Let us start one by one. The first rule says that information representation. It talks about the information representation. It means all information in RDBMS is represented explicitly at the logical level and exactly one way as value in table. So it is very important. It is basically a logical representation of your data or of your information in a table. If you store something in database table, there will be no physical existence which will be visible to you in an operating system, say in your D drive, C drive, E drive. If you want to read this data, then definitely you have to enter inside the RDBMS, then only it will provide you the facility to represent the information in a logical manner. So logically it will be defined. This is first characteristics of the DBMS if it is being qualified for the RDBMS. And whenever you are defining or you are storing the data in a logical manner, then you should ensure that the guaranteed access. So each and every row in the RDBMS is guaranteed to logically accessible by using a combination of table name, primary key value and column name. So it should not be failed anytime during the access of database. If it is a logically it is stored, logically it is defined, then I should have a guaranteed access of this data by using some concept of table name, primary key and their column name. I should allow to extract the desired information from this database, then it is one of the important criteria to qualify a DBMS as RDBMS. Now, we should also have a systematic treatment of null value in DBMS. So in RDBMS, there is a provision of null value. Very, very important. Null is not zero. Please understand here, your database system or database management system should allow to the user to store the null value in a table. So most of the time it is available, but in some of the database in earlier times, the null value inclusion was not allowed. That time when you are not storing any value in your table, then it will fill the value with your 0. If you just do this experiment with MS Excel, you can also create the tables there, but you define a data type as a number for a column, and if you are not entering any value there, so by default it will fill some value, say 0 or 0.0 something like this. It will not keep the column as a blank. So blank is very important and it will be very critical, especially when you are playing with the numerical data. For example, suppose you are storing the say wind speed from your automatic weather stations, and due to some problem, technical issues, your observatory could not record the wind speed value for a certain interval, and if it is null, then the meaning of this data will be different. If it is 0, the meaning will be totally different. So that is very important. So it says that all the database management system which are qualified for RDBMS should provide me opportunity to store the null value in my database. And then dynamic online catalog based relation model. This is another characteristic of RDBMS. The database description is represented at the logical level in the same way as ordinary value data, so that authorized user can apply the same relation language to its integrations as they apply to the regular data. So basically, it says that you have to give a dynamic online catalog based relation model. So at the different level of users, the relationship will be maintained as it is. So it's not changed at any level. That is a very important characteristic of any RDBMS. The next rule is basically comprehensive data sample language. Most important point here, if you want interact with your data, if you want query with this data, then you should have a comprehensive data language, and this data language is basically a medium between the user and data. If I want to ask some question or want extract some information from my data, I must have some language for that. Please understand here, for this purpose, all the DBMS or RDBMS are having a common language called as a structured query language, and this particular SQL, it is not a programming language, it is being used to interact with database or to extract the meaningful information from database. And this is defined by Dr. E.F. Codd. The comprehensive data language or sub-language is must, it should be available, or all the DBMS must be supported by structured query language, then it will can qualify as a RDBMS. So view updating, it is another important characteristics. Change can be made to the table must affect the desired change in the view. Please understand, here we are using one terminology called view. Basically, view is a logical structure, of a table. What we can do here, suppose you have a big table of student record and you want to create a view of a student table by adding only two columns, the student name and class. So in this case, this view can be treated as a table, and your RDBMS must have a provision that if somebody is updating in the view, it should update in, if somebody is updating in table, it must update the value in the view also. Another basically logical partition of your table, it is very important, and in fact it is available in most of the DBMS, but it is one of the important criteria for RDBMS also. then your RDBMS must have high level update, insert and delete operations. It must have the high level data manipulation, not only selection of data. So sometime some of the older time DBMS were providing only the data selection opportunity, but it says that the updation, inserts and deletions are equally important. In fact, nowadays almost all DBMS are providing this kind of operations, but it is an important characteristic of RDBMS which must be integrated in this particular in DBMS software. And next point, it says that the distributed independence, the data manipulation some language of RDBMS must enable application program and inquiries to remain logically the same whether and whenever data is physically centralized or distributed. So it says that the distributed independence, so either database is a distributed or centralized, so there must be basically a logical relationship between these two data sets, which is must in RDBMS. And another point is subversion, which is one of the most important criteria. It says that if a relational subsystem has low level interface, that low level interface cannot be used to bypass the integrity rules and constraint expressed in the higher level relationship language. This particular rule is very important and critical basically. What happened many times, we apply many constraints or maybe many relationship in our tables or tabular structures, but sometime if your database is not secure or is not designed properly, or RDBMS package is not that much powerful, sometime by using the machine level language or assembly language in many of the DBMS, people are able to break this constraint or are able to break these policies in the database, which is not correct. So it is related to security. In fact, the most of the DBMS which are not qualified as fully as a RDBMS are lacking in this particular point. It talk about the security. It says that any security implementation implemented in your DBMS should not be breakable through any low level programming language like machine language or assembly language. Very important point here. And next rule says that the physical data independence can change physical view of the database without affecting the conceptual or logical view. It is basically a logical level definition of your data. If you go through the literature of this DBMS, we have different level of views in the basically DBMS, like we can say the physical view, logical view and a database. So it says that the physical data independence means if I am changing the top level or top view of this database table, it should not affect the physical existence of my database in a table. So logical data independence same way, and the integrity constraints specific to a particularly relation database must be definable in the relational data sublanguage and storable in the catalog, not in the application program. Very important point. It talk about the metadata. So if some integrity independence, basically if you are updating or defining the structure, it should be defined in the catalog level, not in the program level, and it is related to something development of the software application using the database management system. So then relational model, data structure, integrity custom, already we discussed about it. Yeah, these are the another terminologies which will be used especially in your GIS, also in RGS and all. There are different things like domains, attribute, relationship, and if you see here, domain is basically domain name. You can see here this is a complete set, and relationship I was mentioning about the flight schedule or flight number, this particular key, and the attribute already you know about it. These are the field name in the database model. In the relational model, integrity constraints. So how to maintain the integrity? Basically, it is being used this key concept and like a primary key, entity integrity, referential integrity. And here you can see typical example I was mentioning about the flight number or flight schedule and the departure airport. You can see here the relationship between these two things are there, flight duration and flight number. And the like here three tables are shown. One is a flight schedule, customer and reservation. If there is some flight number mentioned in this flight schedule, and only for this flight the reservations are possible. So that means there is a integrity or reference integrity between this table here. Without any flight number in flight schedule, the reservations are not possible. This is one reference integrity you are maintaining. Same time, if you are doing the reservation date and customer number, and any customer number can be unique here, because one customer number for one flight, only one customer number can be used here as a unique entity, and the detail about this customer will be available in the customer table. So in the same way, if some customer number is not available in this table, but detail of this customer is available in this table, then the integrity are not maintained. The data integrity is less, the integrity is lost here. So that way you see the reference integrity here in these two tables, customer and customer number and customer number into these two tables is maintained through this customer number, and here it is maintained through the flight number. Now relational model operations you can understand here, like powerful set oriented query language, very important, but we are discussing about the SQL. And then we have the relational algebra, where the procedural describes how to compute a query, operators like join, select, project and all. And the relational calculus declarative description describes the desired result like SQL QBE, and insert, delete and update capability in the database. So these are the some of the operations. Right now you should understand only most important is join and relate, and then SQL operation like your arithmetic operation with your record set in table itself. So there are some important terminologies here in the relationship model, like operations. Typical calculus example like SQL, select flight number date from the reservation R customer C, where R dot customer number is equal to C dot customer number and customer name is equal to this. So this is a typical query where this is a SQL statement basically. We are trying to extract the flight number and date and flight number from the reservation and customer table, where the customer number are same and the name of the person is Leo. So this is the typical query what can be extracted from this particular data structure. And some of the example for the algebra example you can see here. So reservation join customer, where customer name is equal to Leo, so flight number and date. So basically we are doing the join operation in the this particular SQL statements, and this is a typical example of the algebra. So domain calculuses are examples. Here you can see there reservation and customer, already explained in last slide. The similar things are. Now, although there will be a separate lecture on the spatial database concept, and that time we'll be discussing more about these RDBMS for the GIS data. But quickly I will go through it, how this kind of data models can be used in GIS. And here one important terminology is very important, is basically object oriented model. It is based on the object oriented program. This is like a Simula is a programming C language, C++, Java. And here what we are doing, it's a very important point. Just quickly I will spend some time here, the concept of object orientation in the database. In general, I explained that there are different type of data types available in the database to define the data, like text data, numeric data, or real or float or date time. But our GIS data, raster or vectors, cannot be defined using these data types. See, if you see the vector data basically it has few characteristics, like it has the shape of the feature, on behind it has the database, that is attribute attached with this. Then we have the coordinate system, projection data asteroid. If you combine all together, it is a complex architecture which cannot be defined by a single data types, like cannot be defined as a text, cannot be defined as a number. Then how to define it? So here what we can do in the database, if my database management system or my relational database management system is supporting me the object orientation in database, then I can create the object in database, and these object can be used as a data type. For this example is like if I am able to create the data object for the line feature, for the polygon feature, or for the say point. So first I have to define the structure of this line. For example, say what do you mean by line? Line is a basically by joining 2 points, it should have a start point and end point. If you combine together, it will become the line. Now this is a definition if I am giving to my database. Then second point, first I will define the structure. After that I have to define what kind of operations are allowed with these lines. So basically if you try to understand the object orientation, it will not only define the data structure but also the operations that are possible on this data structure. Then it is known as the object orientation. The same concept will define the database, like this will be the line and these kind of operations are allowed with these lines. It will have the overlay analysis, it can do the buffer analysis, you can do the network analysis. These are the operations. So this is basically object orientation concept. And nowadays most of the RDBMS are providing this kind of object orientation properties, and when it is available, then there are ready-made tools are available today like a PostGIS. It will create a object for your geospatial data and also some procedure and function to do the operation of these data sets. Now if you see here, this is a typical architectures. There will be separate class on that, just I am giving you an introduction on that part. The spatial database management system, it is a 3-layer structures. It's a spatial applications, core spatial functionality like data types, operations, query language, algorithms, access methods, and then finally DBMS. These are the 3 architectures, basically 3 tiers, which will be used to manage the geospatial data inside the RDBMS. And then you can also perform some of the spatial query language, like you can use the spatial query language like temporal query language, object query language, object oriented structure query language. These are readily available for performing the complex analysis with your geospatial data inside the RDBMS. Let us try to understand little bit on the spatial relationship, and these are the like a topological relationship, metric relationship, and directional relationship. If you see the topological relationship, the constant like content overlapping. For example, this is a typical example. You can see A and B. So beside the A and B, this is a common area. This is known as a topological relationship. If you see the metric relationship, it is a distance between object. Example, you can see here A and B. These are the 2 points. What is the distance between these 2 points? For example, it's a 1 kilometer. And this is a 1 kilometer is a relationship known as a metric relationship. And then we have the direction relationship like north of south of, like you can say north to this is available, south in south direction that is available. This is also a relationship. In the spatial database system, if you are storing this kind of data in the RDBMS, then you'll be defining relationship in the RDBMS by using the key concept, and these relationship will be very important to perform the spatial analysis or operation in our data sets. If you see the topological relations, you can understand here topological relationships are defined using the point set topology concept such as boundary and interiors. And topological relationship typical examples you can see here. The boundary of a region consists of set of curves that separate the region from the rest of the coordinate space. The interior of region point in the region that are not on its boundary, and given these 2 regions are said to be adjacent if they share part of the boundary but do not share any point in their interior. So these are another topological relationship. Basically here you will be learning about the adjacency, continuity, and the these are some relationships: contiguity, connectivity, associations. And under this topological relationship, these are the very important things. and we have to define in our RDBMS. And in fact, nowadays the RDBMS are providing the opportunity to define this kind of relationship in database itself. So basically, to just summarize it, the spatial database management system is the organization and management of geospatial data inside DBMS or RDBMS has emerged as an exciting and challenging area for GIS professionals during last decades, which is known as a spatial database management system. Basically, SDMS is an idea to store and manage your GIS data inside the RDBMS. For this, one model that is known as the PostGIS is very popular, which is using the PostGRE SQL as a RDBMS in background, and it allows the especially enables the PostgreSQL server, allowing it to be used as a backend spatial database for geographic information system, much like ESRA SD or Oracle Spatial extension. Here, basically, if you include this third-party extension for the PostgreSQL, it will allow you to store and manage GIS data inside RDBMS. So PostGIS follow the OpenGIS simple feature specification for SQL and has been certified as a compliant with the type of functions profile. And PostGIS development was started by Reflection Research as a project in open source spatial database technology, and it is released under the GNU, that is General Public License. And PostGIS continue to be developed by the group of contributors led by a project steering committee, and new feature continue to be added. Here today it supports the raster vector, both kind of data set, and also 2D and 3D data sets, and then you can perform many analysis with your SQL queries itself. So if you see here the PostGIS model, it supports the storage of the following GIS object type: point line, polygon, multi-points, multi-line, multi-polygon, geometry collection. These are some of the ready-made objects available inside the PostGIS, by using which you can store and manage your spatial data inside the RDBMS, and also you can establish the relationship between your non-spatial data pair itself. So during the next class, you will be learning that about the spatial data models, how the spatial data is being organized and managed inside the RDBMS rather other than your file-based system. So that's all from my side on this non-spatial data. I try to link the DBMS, RDBMS with GeoRDBMS level, how this kind of data models are useful and what are the advantage of it. In fact, in a 1 or 2 lectures, we cannot complete this particular subject. If somebody is from the IT background, they knows that at least in a complete 1 semester, they are studying this database concept. There is a big textbooks are available from the different authors. You can refer to it. But in this particular lecture sessions in 2 hours, basically 1 hour last time and 1 hour today, what I try to summarize it, a complete nutshell or complete a package kind of things for the GIS users, how they can use non-spatial data model to organize and manage their non-GIS data sets, and then once they are organizing and managing, how they can link this data with the your spatial data and further analysis they can perform with this DBMS. So thank you very much for your kind participations.